This video is going to review empirical and molecular formula calculations. So an empirical formula is the lowest whole number ratio of atoms. And it's important because we can find that from laboratory data, and so we can figure out what a substance is. So the little rhyme that helps us remember all the steps into calculating an empirical formula is right here. So you're going to take percent, convert it to mass, then mass converted to moles. You're going to divide by the smallest number of moles, and then you will multiply till you get whole numbers so that we can write a proper chemical formula. So in this one, we have two elements. We've got 40 something that has 43.6% phosphorus and something that is 56.4% oxygen. All right, so percent to mass, if we assume 100 grams, that makes this first part very, very easy. So 43.6% of 100 is 43.6 grams of phosphorus. And then again, assuming we have 100 grams, this would be 56.4 grams of oxygen. So we've done this first part of the rhyme. Now we need to convert mass to mole. And to do that, we need to use molar mass from the periodic table. This one's going to be very easy because it's just the element itself. So the molar mass of phosphorus is 30.97 grams per mole. Gram is here, grams has to go here. So 30.97 grams in 1 mole of phosphorus. For oxygen, it is 16. So 16 grams in 1 mole of oxygen. We want to calculate our moles, and when we do that, we want to use the proper number of sig figs. So each of these numbers here that we were given have 3, and that's how we should report our answers in this next part. So divided by 30.97. So I get 1.41 moles of phosphorus, and then the next one, 56.4 divided by 16, I get 3.53 moles of oxygen. The smallest number here, okay, so I've done this next part, converted them to moles. Now I need to find the smallest number of moles that I've here calculated, and it's going to be this number. That's our smallest one. So I'm going to divide all these numbers by that smallest number of moles. So that's 1. And then 3.53 divided by 1.41, and that gives me 2.5. Empirical formula calculations have special rounding rules, and in a number like 2.5, you cannot round this to 3. What you're going to have to do is this last part of the rhyme, which is multiply until you get a whole number. So 0.5 times 2 will give me a whole number. So I'm going to multiply this by 2, but what I do to 1, I have to do to all. So that means here I get 2, and here I get 5. That tells me I have 2 phosphoruses and 5 oxygens. So my empirical formula is P2O5. So that's the lowest whole number ratio of the atoms. So that's the correct answer, my empirical formula. Now, a molecular formula, just to give you an example, is some multiple of this. So something I've multiplied the subscripts by. So if I multiply the subscripts, both of these by 2, I get the molecule P4O10. So this would be a molecular formula, and this would be its empirical formula. And so what we're going to do next is this problem here that has to deal with finding our molecular formula. So if we're going to find our molecular formula, what we're going to do is we're going to find this little X factor, which is what you multiply all the subscripts by. And our empirical formula in this problem is CH. So I need to find this X factor. It is the molecular formula mass that's always given in the problem, divided by the molar mass of my empirical formula. So my molecular formula mass given in the problem is 78.11 grams per mole. And I'm going to divide that by the molar mass of my empirical formula. So I have 1 C and 1 H. Carbon from the periodic table is 12.01. Hydrogen's 1.01. So if I add those together, I get 13.02 grams per mole. That is my molar mass of my empirical formula. So I'm going to put that up here, 13.02 grams per mole. And then I'm going to divide. This should give me a whole number. If not, I've done something really wrong. And I'll need to just go back and recalculate. And I get 5.9999, so that's 6. All right, now what do I do with this number? I multiply all the subscripts of my empirical formula that was given to me in the problem by that number. So my empirical formula was CH, so it's going to be C6H6. And that's the answer to that problem.